Alrighty. Now, before we look, I'm not going to go into detail too much with different pathogens because I'm going to spend, when we do the disease section, we're going to spend most of the time on defence. But one really good experimental design type question is this one, and up on the screen. And I thought we had it. Actually, yes, there's a picture of it, sorry, on page 77. A picture of it on page 77 first. And back in 150, 200 years ago, even top-line doctors thought diseases were caused by spirits, particularly evil spirits. If you'd been less than good, you're more likely to contract a disease, many contended, and succumb as a consequence. But there were various scientists around back then who thought, nah, this can't be right. And there was one scientist, Louis Pasteur is his name, famous French scientist, who at the Royal Symposium, or the symposium in Paris, a medical symposium, he wanted to disprove this theory that evil spirits cause disease, this theory of spontaneous generation. And he created this nifty little experimental design to do so. He set up 7 conical flasks. And in each flask he put in what we call broth. Broth is like soup. Bacteria love it. If it's uncontaminated, it's nice and clear brown, like black tea. Very nice, smells good, etc. And Louis set this up so that evil spirits still need to get through openings, as you're probably aware. So he contended, all right, of these 7 flasks, 6 of them have openings, so they'll go off. But the one that doesn't have an opening after he made his flask, that stopper, the rubber stopper, will keep out any evil spirits. So this one should remain clean, according to the theory. So he set up some broth. He didn't heat it in the first flask, just left it as so. He boiled the broth here and stoppered it, because boiling, as you're probably aware, is supposed to kill spirits too. He boiled the third one, but left it open. Now the last 4, he pressure cooked. It's called autoclaving. When I was a kid in the Latrobe Valley, that's where I got tough. The pressure cooking food means that you burst open cells. It kills all bacteria, okay? So he autoclaved one solution, left it open, autoclaved a second one, put in a swan neck tube, autoclaved this one, vertical tube, autoclaved the last one, upside down U tube. And he said, gentlemen, because there were no female doctors back then, I'll come back in a few days and let's have a look at the results. So fair enough. Wheeled the trolley back in a few days later. And of course he had repeats. In an exam, if you're asked to design an experiment or critique someone else's experiment, can you just say perform repeats? Okay, you must give a figure, and the figure should be at least 50. Go 50 or 100, but never just say repeat, or repeat 3 times won't get you a mark either. Okay, the world is your oyster, you've got all the money at your offering, so just go for it. All right, always give a figure. So Louis had many repeats, say 50 repeats of this. Okay, so now bacteria, with every inhalation you're making at the moment, you're inhaling bacteria, you're taking them in as spores. Bacteria only become active when they can get in a moist area and they can pop out of those spores and then start dividing by binary fission. Does boiling, by the way, kill bacteria, all bacteria? No, not all. Good, okay. Alrighty, so Louis had these 7 setups. Can you predict, please, which of these setups do you think, bacteria love broth, which do you think went off the most first? Yeah, number 1. Number 1 always went off really well. Not only could they get in through the opening as spores, but you've got all these, you know, when you eat a sandwich, with each bite you're eating thousands of bacteria too. You just don't think about it. Your stomach acid takes care of them. All right, so what's next, do you think? Which one went off next? 3, yep, 3 tended to go off next. Now it's between 2 of them that went off next most. 4 or 2, 2 or 4, correct? Good. So they went off the next. This one, because if you just need 1 spore in here, by the end of the day you'll have 1 million bacteria under ideal conditions. And here, even though you've killed them all, just 1 get in, same story. Alrighty, 5, 6 and 7. Which do you think went off next? 6, good. Okay, 7, 5. All right, well, we'll do a vote. Yeah, we'll go democratic. All right. Who goes? No shame. Don't look around to see if others agree with you. Who goes 5? All right, almost 50%. So I'm expecting probably the other 50%. Who goes 7? Yep. Who didn't put their hand up? 1 person, 2 people. Why didn't you put your hand up, sir? No idea? What about you, young lady? Same? Okay. Yes? Have you been in one of my things before? Oh, bugger. Okay. The young ladies right over here, 5 and 7 were crystal clear a few days later. He could have waited a few weeks, a few years. They'd still be crystal clear because the bacterial spores can't get into the solutions here. There's no wind, but Louis did his coup de grace. This is what really set the world on fire. He picked up number 5, tilted it so the broth could run down the tube until it just made contact here for an instant and then put it back up again. He said, gentlemen, I'll see you tomorrow. And fair enough, came back in, stinking like crazy. Louis had shown that particles here, he didn't know them as bacteria, but particles had made the broth go off once they could mix. Excellent study design, or excellent design of an experiment. Brilliant piece of work. You impressed? I was impressed. Good. Excellent.